Hello my dear students, welcome back. In the last lecture, you have seen that we have discussed the second type of principle of mathematical induction by this question 10 raised to power 2 and minus 1 plus 1. This whole expression is divisible by 11. And obviously, you have already known about the solution of these type of questions. Now, I'll give you some more examples related to this type of questions. So that's why you can easily approach to different type of questions related to this topic. So here the question is to prove 41 raised to power n minus 14 raised to power n is divisible by 27. Okay, so the solution will be similar. By induction you have to prove. It is mentioned in the question by PMI. So let P of n equals to 41 raised to power n minus 14 raised to power n, and step 1 is a multiple, this expression known as multiple. Okay, actually I have shorthand practice with the multiple written in this form, so but you can't write like this. You have to write the complete word multiple of 27. Means you have to prove this expression is a multiple of 27. Means when you have the division factor, you will get remainder 0. Fine. So P of n equal to 41 minus 41 raised to power n minus 14 raised to power n is multiple of 7. So for the step 1, P of n to prove is true for n equal to 1. Okay. So put n equal to 1 in P of n. You will get P of 1 equal to 41 minus 14. Means 11 minus 4, 7. And 3 minus 1, 2, 27. 27 is a multiple और 27, yes 27 का मल्टीपल है ये नंबर. whenever you divide you will get remainder 0. मल्टीपल का मीनिंग ही ये होता है कि that expression should completely divide the complete polynomial or expression. So yes, 27 is a multiple. Every number is a multiple of itself. You can say that also. So P of 1 is true for n equal to 1, or P of n is true for n equal to 1. In the step 2, let us suppose the similar one. Let us suppose P of n is true for n equal to k. So you can put n equal to k in the place of n. So P of k equal to 41 raised to power k minus 14k. So you can write 41k minus 14k in this type of expression. You can easily write 27 into m. Okay, we have discussed this is the definition of division algorithm. Fine. So where m is any positive integer, a whole number, or a scalar, you can easily. Step 3, to prove that P of n is true for what? N equal to k plus 1, for some k belongs to positive integers. Okay, so now we know that P of k plus 1, it means to prove either P of k plus 1, 41 raised to power k plus 1 minus 14 raised to power k plus 1 is a multiple of 27. Clear? Therefore, now we have to start with the similar manner. 41 raised to power k plus 1 minus 14 raised to power k plus 1. You can easily write separately in the form of like this, minus 14 k into 14. So in the step 2, we have already discussed this one. 41 raised to power k minus 14 raised to power k equal 27m. So 41 raised to power k equal to, you can easily find out the value of 41k equals 27 minus plus 14k, or you can find 14k equal 27 plus minus 41 raised to power k, but I chose this value. Fine. 41 raised to power k, so I substitute in the place of 41 raised to power k equal to 27 m plus 14 raised to power k into 41 minus 14k into 14. Fine. So sort it out now. 27 m into 41 plus 41 into 14k minus 14 into 14. Okay, I can write, because the product is commutative, so I put 14 in the front of this term and 14k into this way. So now 27m into 41 plus 41 minus 14, because we have common 14k. If we have 41 minus 14, then 27m into 41 plus 14k into 27. So you will get 27 common out of this. 27, you will get 41m plus 14 raised to power k. Clear? So yes, this the remaining part, it's a multiple. So this complete bracket 41m plus 14 raised to power k is a multiple of 7. Yes, you can easily verify it by yourself. Take any positive integral value for m and k. This is your homework. This is your own verification, and sort it out. Take any value of m, which is positive integral, and any value of k. Put that value in this expression and then multiply that value in 27. Whenever you get that particular output by solving this expression, by the substituting of m and k any random positive integral value, you can easily watch it out. You will easily see that the output will be definitely multiple of 27 as per the question. So yes, 27 into some r, suppose this value becomes r, is a multiple of 27. So by the result, this value you can easily write, because we have end with the space here, so you can write, I'll put it in that manner. So you can write p of k plus 1 is true for n equal to k plus 1, and by PMI result is verified. Fine, for all n. So by the next question, is solve 3 raised to power 2n plus 2 minus 8n minus 9. You can easily see that I take this complete expression, which is a complete heavy expression. I have to prove that this complete expression is divisible by 8. Fine. So put so by putting this expression p of n equals to 3 raised to power, this one is divisible by 8. So by the step 1, put n equal to 1. Now I'm writing the expression in the direct form. You can easily write the expression in the theory form by step. 3 raised to power 3 minus 8 into 1 minus 9. 3 raised to power 3, 27 minus 8 minus 9. You can easily find it out like this. Sorry, here we left with the complete equation 2n plus 2. So it is 3 raised to power 4. It will become 81. 81 minus 17, you will get 64, which is yes divisible by 8. So yes, p of n is true for n equal to 1. Step 2, let us suppose p of n is true for n equal to k, for k is some positive integer or scalar or some natural number. So therefore p of k equal to p of 3 raised to power 2k plus 2 minus 8k minus 9. So equals to 8 m by divisibility algorithm or by divisible definition of divisibility. So in step 3 we have to prove that p of n is true for n equal to k plus 1 for some k belongs to positive integer. Now put that is to prove 3 raised to power 2 k plus 1 plus 2 minus 8 k plus 1 minus 9. This complete expression is divisible by 8. Therefore, we can start with this step. 3 raised to power 2k plus 2 plus 2 minus 8k plus 1 minus 9. So 3 raised to power 2k plus 2, put this term in the bracket form. You can find the value of 3k plus 2 from the second step. I'll write the substitution part of 3 raised to power 2k plus 2 directly from the step 2, because we have discussed 2 or 3 questions before to write the steps similarly, so you can easily understand this step. We have to find the value of some expression from this step to get the value from the step 2. So 3 raised to power 2k plus 2 equals to 8m plus 8k plus 9, and you can write 3 raised to power 2k plus 2 into 3 raised to power 2. Okay, so the bracket one 3 raised to power 2, this one minus 8k minus 8 minus 9. So 9 into 8m plus 8k into 9 plus 9 into 9. Actually, I am solving this bracket, and minus 8k minus 17. So now solve 9 into 8m. There is no another value which is in m, so leave it single-handed form. Plus 8k into 9 minus 8k. So it is 72k minus 8k, 64k plus 81 minus 17. So you will get 9 into 8m plus 64k plus 64. You can easily find common 8 from this bracket. You will get 9m plus 8k plus 8. So this expression is definitely satisfied for any random value of m and k. You can easily check it out as per your requirement for the value of m and k. So here we prove that if we multiplied, you can verify like this. If you put m equal to 1 and k equal to 1, it is not compulsory to take the similar value. You can say, you can choose different values for m and k, but it should be positive integer. So you can easily 9 plus 8 plus 8 multiplied by 8. 9 plus 8 17. 17 plus 8 into 8. 25 into 8, it is 1000. 1000 divisible by 8, yes. So 25 into 8, it's 200 by 8, yes, it is divisible by 8 and remainder will be 0. So yes, p of n is true for n equal to k plus 1 for all k belongs to some positive integer or some scalar, a random number, and by PMI it is true for all n belongs to natural number. This last line is compulsory for the end of any question. So here we have discussed the 3 questions related to the second type. The first question in this lecture is this, and the second one is about this question, and third one is this. So students, please keep watching videos on the series of mathematical induction, and keep safe, stay at home watching the videos. Thank you so much.